Question number 106. Assertion is given, carbon-oxygen bond order in carbonate ion is 1.33. This assertion is a correct statement. Now, what's the reason behind that? The reason is given, carbonate ion has 3 equivalent resonating structures. This reason is also correct. Actually, if I talk about the carbonate ion, it is represented in this way. You know that. And here is the resonance in this case, and it can be represented as double bond at this side, and here is the negative charge. Further, it can also be represented as in this way. It means if I talk about carbonate ion, it has 3 equivalent resonating structures which I've drawn here, and due to the bond order in this case, neither 1 nor 2, it becomes 1.33. And that's why the answer for this question becomes option 1 that you should choose. After that, question number 107, assertion, compressibility factor of hydrogen gas is greater than 1 at 273 Kelvin. This is correct because Z value for hydrogen is 1, is greater than 1. Now, what's the reason behind that? The reason is, let's check what's given here. Intermolecular force of attraction of hydrogen gas is negligibly small at 273 Kelvin. This is also the correct statement, and even you can say that this is the reason also, because intermolecular force of attraction in case of hydrogen gas are negligibly small. That's why it is quite difficult to compress that gas at 273 Kelvin temperature. And that's why for this question also option 1 becomes correct option. Let's take question number 108. Statement A, that's assertion. Spontaneous process is an irreversible process. Generally, the spontaneous processes are irreversible processes. That's why assertion becomes true. Now, if I talk about reason, temperature is the measure of average chaotic motion of particle in the system. If I talk about spontaneous process, those processes for which delta S value is positive are termed as spontaneous process, and these are generally irreversible process. Assertion is quite true. If I talk about reason, so that temperature is also the measure of the average chaotic motion of particles in the system. This is also true. But is it the reason for the assertion? No, definitely not. And that's why answer becomes option 2, where reason is not the correct explanation for assertion. After that, question number 109. Assertion is given, hydrolysis of ammonium nitrate is an example of cationic hydrolysis. If I talk about ammonium nitrate, that is NH4NO3, you know that, and during its hydrolysis, this ammonium ion, when mixed with water, it forms ammonium hydroxide. Along with that, H plus ion gets released. It means acidic solution is obtained. That's why it is an example of cationic hydrolysis. This is true. Assertion is correct now. Ammonium nitrate is a salt of weak acid and a strong base. This is given as the reason. If I talk about ammonium nitrate, it is the salt of ammonium hydroxide and HNO3. It means weak base and strong acid. It means reason becomes incorrect. If assertion is correct and reason is incorrect, then definitely we need to choose option 3 as the correct answer. Now, there is another question, question number 110. Assertion is 27 gram of aluminium reacts with 32 gram of oxygen to give you 54 gram of aluminium oxide. The simple question based on mole concept and limiting reagent. So first we need to write here the balanced chemical equation. Aluminium is reacting with oxygen, giving you Al2O3. In this case, I will mark here 2, and this is 3 by 2. So I have this reaction here. Now, 27 gram reacts with 32 gram of oxygen. It is given in the question. Let's check. With the help of stoichiometry, you will see here that 2 into 27 gram of aluminium is reacting with 3 by 2 into 32 gram. further. If I talk about Al2O3, we have to check its molar mass. You'll see it is 27 into 2 plus 16 into 3. This would be, and it is equal to 102 gram. Let's compare it with the given mass. 27 gram of oxygen, aluminium is there. So it should react with, definitely on the basis of stoichiometry, you will see that it will react with 24 gram of oxygen, and here would be the formation of 51 gram of aluminium oxide. This is as per stoichiometry. Reaction stoichiometry I am using. Now, but as per question, it's given that 27 gram of aluminium will react with 32 gram of oxygen to give you 54 gram of aluminum oxide. That's wrong, because 27 gram will react with 24 gram of oxygen to give you 51 gram of aluminum oxide. It means your assertion is incorrect. And if I talk about the reason states, in the above reaction oxygen act as limiting reagent. So definitely this is also incorrect, because in this case sufficient amount of oxygen is present. 32 gram of oxygen is there, while you need only 24 gram. It means limiting reagent is not the oxygen. So what would be the limiting reagent here? Definitely oxygen would be the limiting reagent, and that's why the answer for this question becomes option 4.